Okay, let's move on to the Mongo shell. The Mongo shell is an interactive JavaScript interpreter that has built-in functionality for connecting to and manipulating data in a MongoDB database. Assuming that you have a MongoDB server already running on this machine, to connect to it from the shell it suffices simply to say Mongo. When the shell starts up, it prints out a banner that includes the shell's version number, as well as the name of the database that you're connected to. I recommend getting into the habit of reading these pieces of information. They're useful for detecting unexpected connections or version skew between servers and shells. Generally speaking, it should be possible to use any version of the shell with any version of the server, but occasionally we add new features either to the shell or to the server, which might require the agreement in versions between the two pieces. So it's a best practice to try to keep these versions in sync. As for the name of the database, it's all too easy to type the wrong database name in, or the wrong host name in fact, and connect to someplace that you didn't expect. So just as a sanity check, I recommend reading these banners. As I mentioned, the Mongo shell is an interactive JavaScript interpreter. This means that you can key in fragments of JavaScript and have them interpreted, or evaluated, immediately. For example, I can write a simple loop, and when I press enter, this fragment of JavaScript will be submitted to a JavaScript runtime, evaluated, and its output will be printed to the screen. The choice of JavaScript as an interaction language was made some years ago, and it was motivated by a desire to have a language that was easy enough for people to use, common enough that there are references for it out there, and relatively convenient for simple sorts of scripting purposes. Now, to make life easy, the shell has some functions that make retrieving and editing previous input relatively straightforward. For example, if I want to get the previous line of input, I can hit the up arrow, and I can move around, for example, with the arrow keys, and change the input to the JavaScript shell to comprise a different program. Here I've produced different output than the previous time around. The editing keys that the shell supports are designed to be similar to those of, say, the bash shell, which comes along with many Linux distributions. The keystrokes that are available there are modeled after the Emacs editor. So, for example, if I hit the up arrow to get a previous line of input, I can go to the beginning of the line with Control-A, probably also with the home and end keys if you have those on your keyboard. I can move around with either the arrow keys or with the bash or Emacs customary keys Control-F, Control-B. I can move to the end of the line with Control-E or perhaps the end key, and now I've input yet a third program for the shell to execute. So far, of course, I haven't actually connected to the database. I'm just evaluating fragments of JavaScript. Within this course, our use of JavaScript is going to be relatively simple, so if you happen not to know the language very well, I hope what I've shown you so far is at least recognizable. The syntax of the language is intentionally modeled after languages such as C or Java, and most people find JavaScript relatively easy to pick up. If you happen to be a JavaScript expert, and you catch me doing things that happen not to be stylistically desirable JavaScript, I apologize in advance. In addition to some of the command editing features that the shell has, we also have a variety of built-in helpers. For example, if you type in help, you can see a list of topics that you can visit. For example, I can say help keys to see some information about the key bindings that are available. You might familiarize yourself with some of the other help at your leisure. Further, the shell has the ability to complete tokens of input. For instance, having typed in the beginning of this loop, if I want to have the shell automatically complete a token that starts with PRI, I can type PRI and then a tab. And the shell will complete out as far as it can, provided that PRI uniquely identifies some prefix of tokens that exist in the JavaScript runtime. What I mean by that is that if PRI does not identify any token that happens to be defined in JavaScript yet, then it won't have completed anything. However, I happen to know that there's a function called print in the JavaScript runtime, and so by typing PRI followed by a tab, the shell will complete that token for me. These sorts of things are fairly convenient for interacting with the Mongo shell. Now, in case you haven't familiarized yourself with JavaScript before, I want to tell you a few things about the syntax that will be relevant. In JavaScript, variables are assigned more or less the way that you might expect. X equals 1 assigns the variable x to be 1, y equals abc assigns the variable y to the string abc, and z equals left curly brace, the letter a, the colon, and the number 1 assigns the variable z to be a JavaScript object consisting of the property named a with corresponding value 1. This is analogous to building something like a dictionary or a hash table or a map in some other languages. I can refer to the properties of a variable in JavaScript in one of two syntaxes. If I say z.a, I will retrieve the property of the variable z, whose name is a, in this case 1. Alternatively, I can say z followed by a square bracket, followed by the name of the property that I seek as a string, followed by a closing square bracket. These two syntaxes have similar purposes, but have some differences as well. In particular, the dot notation, z.a, does not permit a variable property lookup. The a is treated as a literal, even though the z is treated as a variable. By contrast, if I assign the variable w to be the string a, then I can look up, using the square bracket syntax, a property inside the object z whose value comes from a variable at runtime. In this case, looking up the property in z whose name is the value of the variable w. So these two syntaxes, the dot notation and the square bracket notation, serve slightly different purposes in JavaScript. Superficially, the dot notation is typically thought of as being a lookup of properties or methods or instance variables within an object, whereas the square bracket notation treats the object more as a piece of data, like a dictionary, and looks up corresponding associations between keys and values. None of these things are strictly speaking how the JavaScript language talks about itself, but that's not particularly important for the purposes of understanding the shell. In any case, this has been a brief overview of the shell and the JavaScript language. We'll be seeing some more JavaScript as we go through the rest of this week. Okay, let's have a quiz. What is the following fragment of JavaScript output? Now there are 4 lines here. The first of them assigns the variable x to the object whose property a has the value 1. The second one assigns the variable y to the value that's the string a. Given that, what do these last 2 lines do? Place the output in the output box.